Your thesis data is probably broken, and here's how to fix it. I've reviewed over 150 student theses, and the number one reason the supervisor sends you back to redo is not the wrong test, it's not the wrong sample size, it's not even your hypothesis. It is dirty data. Messy column name, text where should be numbers, dropout participants that skew every result, missing values that SPSS just silently skips without telling. In this video, I'm going to show you exactly what dirty data looks like and how to fix it in Excel. If you're following along with your own dataset, open it now. If you do not have any data but want to practice with me, you can download the data I use for this video from the link below. The golden rule in data structure. Before we start, let's talk about what good data or clean data actually looks like, because this knowledge alone will save you hours and 80% of every error you can make during the data preparation. So the golden rule is this: one row for every participant, one column for one variable. That's it. Sounds obvious, right? Well, survey export tools violate this rule constantly. For example, Google Forms sometimes even merges column headers across two rows in weird format. Qualitrix gives you metadata that looks like real data without telling you. So what you end up will look similar to this what I have prepared here. This is how the data should look like. You have an ID column, and then you have one variable per column: age, gender, program, semester, and so on. Here in the middle, you have scale items from a scientific scale I use. And what we'll also see is that each row is one participant. This is how the data should look like. Nothing merged, no empty rows between participants, no participant has several rows. So if you have a data set at hand and it does not look like this, that's the first thing you have to fix. What's the first thing we're looking for? Dropouts and missing values. So let's talk about the thing that trips up almost certainly every first-time analyst: missing values. There are two kinds of missing values. First one is dropouts, people who started your survey but never finished it. And we want to look out for isolated missing values inside your dataset. So dropouts are actually very common. In online surveys, you can expect like 30 to 50% of people who click on your survey link but never bother to finish it. So if you have an Excel like me, you can spot dropouts very easily. The first tactic we can use is sharp seeing. So we can see already here are some people who dropped out. If your dataset is a little bit bigger than this one I have here, you can use the filtering system in Excel. So you go to the very end of your survey and you can just filter on the missing values. So the question is, what do we want to do with those dropout people? Should you just delete them? Usually, yes. Half-filled data gives you nothing for almost every analysis. But before you delete them, you should just run a quick check whether you can spot patterns in the dropout rates. For example, I did a survey on stress. It could be that very stressed people were dropping out of my survey. If so, that would be considered a systematic bias, and this is something I have to mention in my discussion later. In my case, I can go and say, okay, just delete those 4 people. Isolated missing data are a very different story. Let's say 3 out of 150 people left at least one item blank. You've got options. Number 1, it's called a list-wise exclusion. The person gets dropped from any analysis that uses the variable with the missing data. In my case here, I have 2 missing data in age. So every hypothesis, every analysis I perform with the variable age would be ignoring these 2 people. As long as the missing data is below a threshold of 5%, clean and totally acceptable in the science field. There's no problem with it. The one big mistake most students make here is that they leave a cell blank and assume that everything is fine. Some programs treat blank values as a 0, and this will destroy the results you will have in your analysis. So you have to treat them, or you have to look out for them. Before we go to the next section, I want to show you a little trick with Excel where you can determine really fast whether you have a problem with your data or not. You press Ctrl F, do a little search, leave the search bar blank, and just look for the number of rows. In this case, we have 2. So 2 out of 120, I think, is below 5%, so I do not have to do anything with those missing data. If they are way more than this, more than 5%, then you have a problem. If you want to see where the missing values are in the whole data set, then we just have to mark the whole data set, and we are looking up every cell with nothing in it. In our case, only 4 participants who left out some of the questions unanswered. This is still under 5%, so in this case, we do not have to take big measures. There's one thing you have to remember. What you always need to report is the final N. How many participants actually went into each analysis. If you have more than 5 to 10% of missing data, list-wise exclusion is no longer a clean solution. There's a far more advanced method, and that's called imputation. This is where you estimate the missing data from the rest of the people who answered your questions. This is something I've covered in my tutorial guide. So for most datasets, you will never need it, but some people who have bad luck in the sample, this will help you along with your data. You export your data from Google Forms, Source Survey, or whatever your tool is. And instead of numbers, the cells are filled in with text. Strongly agree, strongly disagree, rather agree. Excel especially, but also SPSS cannot do math with text. Everything you do with math will return with an error message. To fix this in 2 minutes, you just have to press Ctrl-H, find and replace. Type in strongly agree, replace this with a 5, and then you go replace everything, and it will replace every cell which has something like this in it. If you have a Likert scale, do this for every Likert scale variable that came in as a text. If it already shows numbers, like in my case, that's good. Missing values and everything is a number. The next thing we have account for are outliers. These are values that are technically there, but they are wrong, implausible, or are so big or small that they do not fit in any analysis you want to perform. Classic example is typo. In my case, I have a person who states the one is 222 years old. A different example would be that you have a stress scale which goes from 10 to 50, and someone has a score of 5, that's too low, or another person has a score of 100, which is too high. But what if you have stress score 49 out of 50 or 50 out of 50? That's an extremely stressed person. That's real data. That's something you have to keep, even though it's way higher than the rest. If you're working with Excel, the fastest tool for spotting outliers are Boxplots. Select your column, go to Insert, Diagrams, and then choose Boxplot and Whisker. You just have to look at anything which is outside of these whiskers. So we have our age. We had one extreme outlier, which was a person with 222 years on its belt. And this is obviously a typo. As we do not know what the person wanted to type in, we just delete this one number. And outliers outside of the whisker, that does not automatically mean that we have an outlier that we have to address, or it just means that this could be a potential outlier. So we just have to look at this in a little bit more in detail. Every time you exclude someone for anything, you have to mention it in your methods. So there's one last thing before we move on. Column names need to be short, no spaces, no special characters. So something like this, you have to fill it in with something like an underscore. Most of the analysis programs out there are SPSS, Python. They're not good in handling spaces or special characters. Just do not use it in your header rows. Is every row one person, and is every variable one column? 2. Did you get rid of every text in your Likert scale? 3. You have checked for implausible values and have deleted them or addressed them accordingly. 4. You have checked your column names, whether there are special characters or spaces, and corrected them so that you can load this dataset into SPSS later. 5. Your categorical variables like groups, gender, club membership are numerized. If you've done everything until this point, we can go to the next step. Especially in online surveys, you will come across people who will run through your survey. They fill out every question, but they do not read every question or are so fast that they do not have the chance to read every question. For example, if you have 200 questions, it takes at least 10 minutes. If a person is finished in 2 minutes, you know that it's impossible to read every question. In my dataset I have here, you can see that I have a completion time normally around 600 seconds, and I have a few people who were really fast and who can complete this survey in under 1 minute. So this would be my criterion where I say, under 1 minute, I do not want speeders in my survey. This would be a potential person I could exclude as well. The second thing you want to address is that people who fill out your survey do care on what they answer, right? So you see patterns like 3, 3, 3, 3, 3. This can be completely genuine. So to address this, I recommend to do a little trick, attention check. In my case, I asked the question whether the sky is blue, and the correct answer is obviously blue. But there are sometimes people who answer this attention check wrong. Sneaky but easy way to see who you want to keep in your survey. As for now, my data is clean. They have to be analyzed as well. So in the next video, we're going to talk about the one sentence that determines everything that follows, your hypothesis. And I'm going to show you the most common mistakes students make, which will give you wrong results even if you use the right statistical test. So see you there, have a nice one, and check the link down below. Bye bye.